Greetings, everybody. I want to look at this question, which is, at least at the time I'm making this video, this is question 20 from assignment 2, where we're asked to identify for these points A right here at 53, B right here at 63, and C right here at 78. We're supposed to identify their z-scores, and we're given these choices, like one of those points has a z-score of 0, the other has a z-score of 2.14, and then the last one has a z-score of negative 1.42. Okay, and then it's like kind of like multiple choice. Like the point A, this one right here, right there, has a z-score of, and then there are those choices I went through. Now, let me give you a quick summary of what the z-score is in order to answer this question. So I have all these facts about the z-score. Every data entry in a data set has a z-score. The z-score tells us how many standard deviations the data entry is from the mean. So if one of these points has a z-score of 2.14, that means it's just over 2 standard deviations from the mean. Okay, and we'll get to the point of why that's important in a minute. If the z-score is 0 specifically, the data entry is the mean. Okay, if the z-score is negative, the data entry is below the mean. So maybe now it's starting to add up. Like one of these points, the one with the z-score of 0, is the mean. Okay, and then on that next point, this one with the z-score of negative 1.42, whichever one of these that is below the mean or less than the mean. And then if the z-score is positive, the data entry is above the mean. So, okay, I see one of these z-scores is 0, one is positive, and one's negative. That means I'll match it up with the points where which point is the mean, we'll have a z-score of 0. Which point is above the mean, we'll have a z-score of 2.14, just by multiple choice, just because those are the options I have. There's only one positive z-score given. And then the one with z-score of negative 1.42 is below the mean. Okay. Now, there is also a formula for calculating the z-score. You take the data entry, subtract the mean, and you divide by the standard deviation. And it might seem that that's how we're supposed to do this one. In many of the problems that we have, it will involve calculating some number according to some formula, okay? Or perhaps using StatCrunch. StatCrunch is something that we use to make things easier for calculations. But I don't think that, even though you can calculate the z-score, I don't think that that's practical or necessary in this question because, look at the data like this. First of all, think, what is the mean? The mean is like roughly, in general terms, the middle of the data set. Only one of these points is at the middle. Like if the data is all spread out like this with most of it in the middle and not very much of it on the outsides, the only point that is anywhere near the middle is B. So, if one of these points, A, B, or C, has to have a z-score of 0, it's got to be B. There's no way point C could be the mean and have a z-score of 0. There's no way point A could be the mean and have a z-score of 0. Okay? Now, if B's the mean, then that means that point A is less than the mean and has a negative z-score, right? And then that also means point C is above the mean and has a positive z-score. So it's like by almost process of elimination and the fact that I'm restricted to these choices that I can answer the question and not have to calculate anything this time. All right. So, okay. So point A, this one right here, which is below the mean, has to be the one with the negative z-score. That means z-score can't be 0 and it can't be 2. It's got to be negative 1.42. Okay. In this next point, point B right here. Well, that's in the middle, and if one of these points has to have a z-score of 0, it can't be the ones not in the middle. It just wouldn't make sense. because the mean has a z-score of 0 and the mean is roughly in the middle of the data set. So it's got to be 0. It can't be 2. It can't be negative 1.42. It's like 0 is the only choice that makes sense if those are my three choices. Point C is, if we agree that point B is the mean, point C is the only one above the mean, and it has to have a positive z-score, so it can't be 0, can't be negative 1.42. It's got to be 2.14. Okay. Now, next thing is this. Based on the z-scores, are any considered unusual? So for data that is bell-shaped, and by that I mean like that there's a peak in the middle and it flattens out on the left and the right side, any point that would be more than 2 standard deviations above or below the mean would be considered unusual. 95% of the data in the data set is within 2 standard deviations of the mean, meaning it's within either 2 standard deviations up or 2 standard deviations down. It's kind of like saying like most of the data is in the middle, like as you can see here. So if the z-score tells us how many standard deviations a data point is from the mean, and if I said that being more than 2 standard deviations from the mean is unusual, then this z-score would represent a data point that is unusual. Okay, so we can check the answer, and there we go. So it might seem that there is some calculating to do on this question, and we can calculate the z-score, it's true. But if you understand these concepts and definitions and the meaning behind the z-score, combined with the fact that we're just given 3 choices and the shape of the data set, then we can answer it just based on that alone.